Hello and welcome to the DCD Cloud and Hybrid channel. I'm Alex Dickens, Channel Management Team Lead at DCD, and I'm delighted to be introducing the latest episode in our series, which we're producing in partnership with Digital Realty, which will explore how to balance HPC and sustainability. Joining me today, we have two expert speakers who will share their insights on the topic. I'm delighted to welcome Patrick Lastinet, Director for Platform and Enterprise from Digital Realty, and Matt Armstrong-Barnes, Chief Technology Officer for Artificial Intelligence at HPE. So, to get into it, we've got to start at the beginning and discuss what, in fact, the challenges are attached to high density. Patrick, as Digital Realty is sponsoring, I feel like we should let you speak first. Perhaps you could provide us with a bit of a sync up and a helicopter view on the infrastructure challenges which are happening at the data center level at the moment.
Absolutely, Alex. I'll be glad to. The challenges attached to high density, they are becoming more prevalent. There's really two, I would say, trends that we are seeing. On one hand, we're seeing the traditional HPC workload, so not necessarily AI, but traditional HPC where you do simulation and use CPUs. The roadmap in terms of upgrade of CPUs and ever higher densities of CPUs and higher what we call TDPs or thermal design power of these CPUs mean that air is not sufficient anymore to actually cool these CPUs, these chipsets, which means in terms that the servers need to be built and designed for liquid cooling. So we are starting to see, and it's becoming quite prominent, enterprise and customers approaching us with some large scale and smaller scale as well requirement for deploying liquid cooled servers. So I think this is one of the first big trends that we see. And then in parallel to this, obviously we see the advent of AI and GPU clusters. And similarly here, I think a large part of the servers which incorporate GPUs also require either liquid cooling or very, very high density racks for air cooled solutions. So typically, if we look at numbers today, if you want to play in the HPC and AI segment, you need to be able to support air cooled racks up to 50 kilowatts per rack, I would say. And with that, you also need to be able to accommodate direct liquid cooled servers or air assisted liquid cooled servers from 50 kilowatts per rack plus, and this can go up to 120 and 150 and 200. This is effectively a function of how many CPUs you can put per U. So all this to say, if you look at HPC and training of AI workloads, are starting to creep out of on-prem data center. These workloads are also being repatriated from the cloud, which means that data center providers now really need to be able to accommodate those type of densities.
Brilliant. Thank you so much, Patrick. And Matt, I'll turn it over to you to help assess the lay of the land. And I'm sure you're kind of no stranger to demand working for HPE. But we saw the Gen AI boom occur last year, and we're really feeling the impacts now. But from your perspective, what has been the reality of AI developments? There's so much hype in the market. Maybe you could put us straight.
Yeah, I mean AI, it went exponential when generative AI really became common parlance. But we have to remember that AI, it's not new. I mean, we in Hewlett Packard Enterprise, we've had an AI center of excellence for more than 3 decades. So we've been working on bringing AI technology to tackle some of the world's biggest problems for a long time. So I've been doing this role for 7 years. So 7 years ago, I was explaining to customers in the sort of more enterprise space, what is it? What do I do with it? And I've really seen the sort of evolution of AI change from what is it and what can I do to why am I not using AI? Why am I not bringing it into my infrastructure? And that probably over the past 4 or so years, we've really seen it being brought into organizations at scale. And that brings some challenges in terms of how you manage the logistical aspects of building your AI models at scale, how you deploy them onto infrastructure, how you do that in a sustainable way. I mean, I think IDC have predicted that by 2027, global AI spend is going to hit 500 billion. So it's a massive market that's continuing to grow year on year. Um, Generative AI, the thing that's kind of captured most people's imagination, it is newer. We have to bear in mind that sort of some of the original research happened in 2017. It took 2018 before it became generative, and then we've really seen it grow. Still some experimental areas around it, and it is a case of kind of finding the right use case and making sure that it's going to bring the right value into your organization. So definitely generative AI is here to stay. It's going to become much more prevalent when it comes to enterprise-based use cases, but we're also seeing this continued growth in the more traditional artificial intelligence space, all of which, as Patrick talked about, needs the right kind of compute capability that can be deployed in a highly sustainable way that's ultimately going to allow you to achieve and bring this transformative technology into your organization in a way that provides you the right kind of scale.
Fantastic, thank you. The kind of burning question I'm left with, and I'm sure you've seen customer requirements and the associated problems evolve quite dramatically over the last 6 months, 12 months, and since then before. But where in particular should we be putting these workloads? People are unsure of the scale and exactly how much power they're going to require. The supporting infrastructure. So how do we strategize for this? Patrick, I'll come back to you.
Well, what we see from customers is there's a variety of factors which they need to take into account. Obviously, cost is one, but also they need to think. You need to look a little bit at the workload and understand it in terms of how data heavy it might be. So I think take into account costs, price of energy. Obviously, one option is to located where electricity is cheap. However, then you also need to take into account how much data needs to go to the compute, or do you bring the compute to the data? And I think the latter becomes more and more, the trend of the compute going to the data. So you really need to analyze your workload and find out how data heavy it is. And from there, also overlay any regulatory, I would say, concerns or regulatory requirements which might force you to actually run your HPC workloads in country. So we really see a mix. I think traditionally we've seen large clusters of HPC potentially being, in the Nordics, but we also see that often scientists need to have these quite in proximity from a user perspective. So typically, if you have a large cluster of GPUs, you and you have quite a significant number, hundreds of data scientists working on it, and or constantly loading it with quite heavy data sets. You will have a limit of 5 to 10 milliseconds round trip time. So I think the architecture, people are starting to realize that you need to really take into account the connectivity aspects and data movement and data gravity. So at Digital Realty, we have a platform which spans, across the globe with 350 plus data centers. So we're able to accommodate both scale, or should we say traditional colocation, and we see all sorts. I think the reality is, no one is on a similar journey, to achieve either HPC or their AI objectives. And if you want to serve the maximum number of customers, I think it's important to have that in your tool set is a platform which is global, which allows to offer any type of scale and also is rich in connectivity.
Brilliant, thank you. So to move the conversation on a little bit, I want to spend the next few minutes discussing, what exactly we're building high density for. Whilst we talk about Gen AI, and the hype around HPC, ultimately not everyone is going to be supporting these workloads. So, perhaps we could spend a bit of time kind of breaking down what we mean exactly by AI. Matt, it's not all training and inference, is it? There's a bit more to it than that.
Yeah, so we have to view the AI falls in a number of categories really. So first we need, without data, we don't have AI. And as Patrick talked about, data gravity, where the data is created and the applications that subsequently consume it, we're finding that we need rapid response to the generation of that data in terms of how we gather it. Once we've gathered it, we need to make it ready for how we put it into our algorithms, our AI means of processing that data. So AI is a mathematical technique. So as a result, we need to take it in the data in its raw format and turn it into something that can be used by an algorithm. Once we've done that, we then need to tune these algorithms so that they operate in a much better way. And once we've done that, we need to deploy them. So that means that there are several stages associated with how we go around building artificial intelligence systems. The most computationally intensive part of that is tuning. So tuning algorithms is a very complex space because we've got to tweak these complex algorithms, and then when we deploy them, that's when we perform inference. So again, where the data resides is a critical component of that. And actually what we can see is building the algorithm itself is around 5 to 10% of the overall effort of building the system. It's the stuff that where all the sexy things happen, but really what you need is the right kind of operating support around that in terms of your operating model, how you govern it, how you build your technology stack that supports it, and how you bring in all of the tools in the tool chain that allow you to build these systems effectively. So overall, we can see that there are lots of moving parts when it comes to AI systems. They need to be put close together because of the data gravity around where the data is arriving from. And then we need to make sure that we're using the right kind of operationalization, which takes it from initial ingestion of the data right the way through to production systems using as much automation as we can, because automation drives efficiency, it reduces errors, and ultimately it makes your AI systems deployed into production much more effective.
Brilliant, thank you. You also touched upon the where in terms of said workloads, Matt. Perhaps you could break down, the kind of distribution between kind of, on-prem and cloud, and how those kind of dynamics have evolved over the last 12 months.
Yeah, so I think from a hyperscaler perspective, when we talk about cloud, we're talking about public cloud because you could deploy clouds on-prem. And what we've seen is there was a lot of move towards initially deploy on public cloud-based AI solutions. There have been some challenges around that. Specifically, Patrick talked about data and data security when it comes to data loss prevention, intellectual property, copyright, ultimately how you secure it, but also how you are pro-choice. A hyperscaler-based public cloud offering is much more walled garden, as in all of the things that you need are in one place, and that does mean that there's a degree of lock-in. If you'd go for on-prem deployments, there's been an enormous acceleration in the open source community, bringing together a collection of tools that give you everything that you need to refine your data, gather your data, build your models, tune your models, and deploy your models using an open source stack. That gives you flexibility, it gives you choice, and it also gives you very good options for repatriation. So all the organizations that kind of rushed into a hyperscaler public cloud model are finding that there are some considerations around that. Patrick talked about cost, the cost profile, and some of the scalability that was originally one of the incentive to move there have now been addressed on-prem. And you've got a rich ecosystem of open source tooling that allows you to rapidly deploy this type of technology in a way that is kind of pro-choice, and you can wrap the right kind of scalability options around it, as well as having a better understanding of the sustainability impact and bringing in more choice when it comes to developing these applications, because you've got access to the underlying componentry instead of living in a quite a constrained walled garden type approach.
Mm. Patrick, Matt spoke a lot about this choice. I'm keen, from a colo operator point of view, how are customer requirements shaping up, and do you find that people have an AI strategy?
So as Matt explains, in terms of the workloads, the different phases, the ingestion, the training, and the inference. So far, we've seen traditionally we've seen quite a few data lakes being deployed on our platform. In the last 18 months, there's been a peak on training, and I think now we can see that everyone is thinking about inference.
Brilliant, thank you very much. Matt, I'm really keen to get your perspective as well. When it comes to AI strategies, do you think what we have at the moment is going to hold water, or does more need to be done?
Yeah, so I've got one of my favorite quotes. So it's from Sun Tzu, The Art of War. Tactics without strategy is the noise before defeat, and strategy without tactics is the slowest route to victory. So having an AI strategy absolutely puts you in the best place. You need to answer questions like, how's it going to align to your business objectives? If you're running to AI without understanding how it's going to add value to your business, then potentially you're not going to be tackling the right kind of use cases. Um, Patrick talked about use cases being a key thing. Part of your strategy, how do you prioritize them? There are skills challenges that live in this space. So as a result, having a prioritized strategy that's going to build you to the right kind of success is critical. Um, how are you going to integrate with your data strategy? We've talked about the fact that you need to be close to your data, and as a result, you should have a data strategy. If you don't, the two kind of go hand in hand. So building them out and making sure that you're going to tackle both of them will really help you understand the best way of deploying infrastructure that's going to meet those needs. You also need to think about how you can integrate it. I see a number of AI implementations that are sort of ivory towers. They really need to be integrated into your business to give you the right kind of benefits. Also, how are you going to tackle basic things like risk, compliance, ethical considerations that live around it? How are you going to manage them and integrate them into your existing management regimes? There are a lot of questions that you need to answer associated with the production of your strategy. And in doing so, putting that foundation in place will be a massive accelerator to enable you to deploy AI technologies and really sort of drive the key benefit out of what you're doing and make sure that you're understanding the ramifications of what you're deploying and those considerations around data and making sure that the AI workloads are as close to that data as possible, because data really does have a magnetic pull. It pulls in workloads close to it, and it's quite costly to start moving data around. So making some of those decisions really will be key questions that you need to ask when you build out your strategy.
Fantastic, thank you. In terms of building out your strategy, everyone's trying to, as discussed, build out their AI strategy, but also sustainability agendas are a core part of what data centers have to deliver on these days. Which brings me to kind of my next talking point. How exactly can we go about reconciling AI adoption and growth with meeting our sustainability objectives? There's a lot of hype in the market around how power hungry these workloads are. But what impact is increasingly distributed compute actually having on data center sustainability? Patrick, perhaps you could help us out.
Well, I think certainly the first thing, the first impact, should we say, if we look at sustainability, and probably if the proxy is reduction of carbon footprint, should we say, the first thing is to become more efficient. So um, there is definitely a focus on the efficiency of the data center, which is all captured in this metric, which is the PUE, and obviously everyone is now trying to build in order to achieve a PUE as close as possible to one. Now, I think also what you need to bear in mind is there's a lot of legacy, a lot of retrofitting is taking place, or retrofitting is expensive. So, well, achieving efficiency for the old inventory is also a challenge. So but efficiency is not everything. If you think about it, it's the Jevons paradox. The more you become efficient, the more actually you are going to produce. And in the end, you also need to have an element of circularity, and you need also very important to add, because I think the issue is it is going to scale as such. I mean, the scale is such that we might run out of renewable energy, essentially. So it is really important for the industry as a whole to, as AI grows, to add new sources of renewable energy. So by default, obviously, we uh, supply 100% renewable energy for all our colocation services worldwide. But also, what we try and do as much as possible is whenever we bring a new data center online, we will attach the virtual PPA, which means that a significant new source of renewable energy will be created locally. And I think that's the important thing as well. We need to try, as an industry, to reduce the carbon intensity locally. If the reflex is just to try and shove all the workloads where there is, in the Nordics or places like this, which are already carbon free, we're not really solving for the issues locally. And whether we like it or not, there's always going to be workloads and AI workloads deployed locally close to the data, as Matt was making the point. So I think it's a really tough challenge. I'm very glad that the leadership within digital realty is extremely bullish on innovating around this. Our CTO Chris Sharp was mentioning, potentially us becoming independent and adopting our own small nuclear reactors like SMR. So, it might seem a little bit far fetched for some, but I think we need to be bold in order to address these issues. And certainly we see that, from a customer perspective, obviously it is a concern. But also there is a little bit of a gray area, scope 2, scope 3, whether you deploy in the cloud, whether you deploy private, bare metal in a colocation, you will, the carbon accounting might be a little bit different, the reporting granularity might be a little bit different. So for sure the next 2 to 3 years is going to be a huge subject, and also because of the new regulation hitting the market by 2025.
Brilliant. Thank you. Just to turn it back to you for a second, Matt, keen to get your sense on this too. But, we spoke earlier about the different types of workloads, not all AI is equal. What are the considerations when kind of drilling down into, sustainability when looking after your training versus inference workloads, just to draw that comparison again?
Yes. So firstly, I think the work that Digital Realty are doing around innovation in this space is fantastic. If we view, there was a study that said by 2030, global AI electricity consumption would be the equivalent of the size of country to the Netherlands. And that by 2040, 14% of the planet's total CO2 emissions will be driven by AI workloads. These are massive, these are eye-watering numbers, and we really need to make sure that we are tackling AI in the most efficient way that we can. We've got a responsibility to the generations coming through and to the planet to do this in the most efficient way. And that means building your AI stack in the right kind of way. So it means you've got to think about it from the software that you're deploying in terms of the AI services and how they are efficient and using the most efficient algorithms, and how you're tuning your AI algorithms using highly efficient algorithms specifically for tuning them. But you also need to go down into the hardware. How is the hardware tuned to the absolute utmost levels to make sure that it is squeezing every ounce of value out of the power? We HB do the software and we do the hardware. We've got a great sustainability message. And then where are you putting it? And this is where I really like working with Digital Realty, because they've got such a fantastic sustainability agenda. It goes right the way to the top of the tree, as Patrick was talking about. And it is absolutely fantastic what Digital Realty are achieving in this space, and how together with HPE, how we're ultimately going to drive the agenda in the right kind of way. We have to bear in mind that there are reference architectures that live in this space that really are driving the agenda forward, to make sure if you are tackling AI workloads, don't go and build the architecture yourself around how you're going to put the platforms in place. Engage with Digital Realty, engage with HPE, and we can help you understand how to do that in a highly efficient, optimized way with the workloads in the right locations, so that you are, instead of taking a fragmented approach to how you're building AI workloads, how you're doing it in scheduled or batched way, which is taking high performance compute thinking and applying it into the AI world. Instead of building out these architectures yourself, we've been doing this for decades, and really HPE has an AI native architecture approach to allow, you know, the sum of the whole to be greater than the sum of the parts. It's around deployment of AI workloads using the right location, the right infrastructure, the right platforms, the right models, all built in an architecture that provides services that allows you to build highly efficient models.
Brilliant, thank you. In the most reductive of terms, it sounds like picking the right tool for the job is obviously essential. And as you outline, building environments, for the workloads and for the customer specifically. But as we see kind of the proliferation of end-to-end services and various offerings which aim to support, the growth of AI workloads. The other challenge, of course, is this potential for vendor lock-in. And we want to avoid the challenge of interoperability or lack of it, at all costs. Matt, perhaps you could speak to that a little bit as well.
Yeah, so open source, in terms of HPE, we are big into the open source community. We really are backing it and continue to build out our own capability and provide it into the open source. We have some of the most efficient algorithms for tuning AI models, and we've open sourced them. And we open source a lot of our technology to make sure that it is as readily available as possible. And that means that we're pro-choice when it comes to building out your how you're tackling some of these AI type problems. So you can go to the community. You've got developers around the world that are driving innovation in a way that individual organizations can't, in a way that hyperscalers and public cloud organizations can't. So really it is about embracing the open source initiatives that are driving, but really what you need is open source initiatives that are fundamentally have large corporations involved, because that de-risks it. You don't take on the challenge of bringing open source into your organization. You can wrap it with support agreements, which means that you are compliant from a regulatory perspective. So you get all that speed of change, all that innovation, which you have greater control about, all of which you can have supported and maintained, but still avoiding vendor lock-in, because you have the choice of all of the different open source tools available to you. So we at HPE support the AI Infrastructure Alliance. You can Google it. It's an initiative which is trying to put a canonical stack around all of the various software tools that you have from the open source space together to give you a supported, highly efficient stack that has longevity and is starting to tackle how you build out these things compliant with reference architectures that are industry supported and have a significant number of industry backers.
Brilliant. Thank you very much, Matt. So, Patrick, I want to come to you for this kind of final question on this point. Quite frankly, do efficiency and cost conflict? Do we have to reconcile sustainability in the bottom line as well as sustainability and HPC growth?
So I think cost and efficiency, that there's no contradiction there. I mean, if you look at a typical HPC or AI training workload, the consumption of power is, can go, especially in Europe, can be as much as 60 or 70% of the, should we say, data center colocation TCO, and it can be up to, I don't know, 30% of your total total TCO for the whole stack. So and the power consumption is a function of the efficiency of your data center. So the more efficient your data center, the lower the PUE, the less you pay for the power. Okay, but that's just one point again, is that's just the efficiency, and it's more a cost thing than a sustainable thing. and I think now, if you think about where we want to go in the future with new sources of energy, where we want to go in terms of recycling of critical heat, for instance, there's definitely capex to be invested at infrastructure level by the data center provider or its partners, and it might result in a price, additional price point. Having said that, I think the whoever doesn't adopt a sustainable best practice will be penalized eventually by their stakeholders, shareholders, customers, etc. So the long-term view, I think there's absolutely no contradiction. I think with efficiency, it goes hand in hand. The more efficient you are as a provider, the more better terms you can offer your customers. And potentially that there might be 2-3 years where we need to invest in order to make the whole offering more sustainable. But I think most customers understand, take the long view, and understand that investments are necessary for us to achieve sustainability objectives.
Brilliant. Thank you. Um, and speaking about those objectives, it's obviously the aim of everyone to make sure they scale in line with high density and don't under or over provision. But we've spoken a bit about this kind of evolution of software alongside hardware. But Matt, perhaps you could speak a little bit more to it. Are we talking about maybe a software solution to a hardware problem? And also, how else is software, helping drive benefits across the wider tech stack?
I actually think the software is tackling a skills problem. So, we've got highly efficient hardware, we've got highly efficient software algorithms. And the reason we're doing that is we're starting to reduce the level of skill that is required to build algorithms. Because putting it in the hands of, if every time we need to build a highly efficient, sustainable algorithm, we need people with PhDs in maths who are, a very small number of them who are capable of operating that kind of way. Ultimately, we're either going to build lots of inefficient AI systems or we're not going to build as many as we need. What we can do is we can take some of those smarts, we can embed them into software systems, meaning that it becomes a repeatable means of building sustainable systems. And that's really what we're doing from an AI perspective around building out these software layers. The other one is what we're doing is we're reducing the need to have dedicated resources for specific data science initiatives. If I explain what that means, what we don't want to do is to have lots and lots of acceleration tied to individual projects, because that's not very cost effective, and it means we're going to be using significantly more power than ultimately we need to. So what we want to be able to do is take the world's biggest supercomputer, Frontier in Oak Ridge Labs, is run by Hewlett Packard Enterprise. It is of our creation, and it runs some of the biggest workloads that we have today. Not everybody wants to be running a supercomputer, but you do want all of the smarts around how you deploy some of the most complex workloads that mankind is working on today, brought down to an enterprise level. And that's what we HPE have been doing, is bring all of those smarts down and making them available so that you don't need that incredible level of skill in order to build highly efficient AI systems, because you've taken the high performance compute thinking, which is how I package up my AI workloads, and I submit it as a job to my compute infrastructure, and then some clever software allocates the resources as and when needed with all of the other jobs that it's doing in a highly sustainable way. Ultimately means we're going to be building better systems, smarter systems, more sustainable systems, and systems that can survive for the long term, which means they need less retraining, which means they consume less power, which means they're producing less CO2, which ultimately means that we're going to build them in a better way.
Brilliant, thank you. And Patrick, just to turn it over to you, whilst I don't want to get too bogged down into what's happening at the component level, perhaps you could speak a little bit about how hardware is going to support the proliferation of the workloads further, and what other new capabilities we might expect to be unlocked in the coming months and years.
Yeah, so as I was saying at the start of our episodes, I think there seems to be definitely a trend, a constant here, which is the increase of the thermal design power of the new chipsets. So um, for accelerated compute, which is necessary to train and fine tune new models, we used to be the rule of thumb that I was given is anything above 300 watts, you need to start considering something else than air to sort of cool the components. Now, 18 months later, we are envisaging 1,000, in excess of 1,000 for the new generations. I mean, 1,400, what I've heard. So, in that respect, I think the challenges, the thermal challenges, are going to become they certainly are going to become more and more, prevalent. And we make a point of working very closely with HPE on that front in order to make sure that we've got a good understanding of their roadmap, of how they see, the whole portfolio of their services evolve in that direction. Because when we build our future generation of data centers, we need to understand what are the servers going to look like in 18 months, and effectively we need to come up with a design which is modular enough to accommodate the largest part of the market. And then obviously you need to get the balance right, because not everyone is adopting this at the same time. So if you're on a multi-tenant data center service, you need to sort of think a little bit about your mix of customers and anticipate where it's going. So but definitely the trend, if anything, the risk is probably to be too cautious there, I think. And if we see the rate of adoption is staggering. So I think for us, we want to be able to accommodate any type of density anywhere in the world, basically. And how efficient we are in doing this will dictate our success. And again, the partnerships we have with the likes of HP are absolutely crucial, because these are not things we can just work out by ourselves. We need an ecosystem of partners to help us along the lines, and that includes the likes of HP. But also, we talk a lot with the chipset providers, the NVIDIAs, Intel, AMDs of this world, to make sure we've got good visibility. And if we go into a little bit more in detail, it can be very fragmented. If we need to maintain a dedicated water loop at a certain temperatures, some vendors will say it needs to be this temperature, others will say no, it needs to be that one. So we need to have our own opinion. But we're also blessed with having, a unique, I would say, engineering group. We recently created the Advanced Engineering Group, which is a small nucleus of extremely experienced engineers, which have come across all these types of phenomenons, and who are informing our strategy and engaging, obviously, with the likes at HP as well.
Fantastic. We only have a couple of minutes left. So rather than focus too much on, the outlook for workload growth, at the end of the day, none of us have crystal balls. Perhaps I'd like to ask you both, just to take 30 seconds to perhaps give your expectations for how customer demand is set to evolve. Matt, I'll start with you.
I think we're going to continue. AI is here to stay. So is generative AI. So we're seeing these technologies that have really become a core part of corporate strategy, which means we're only going to see an ever increase in the demand for this type of technology. So I think the things that I would close on are: have a strategy, make sure that you understand how you're bringing this technology in, engage with the likes of Hewlett Packard Enterprise and Digital Realty, because we really do know how to deploy this type of technology at scale and in a highly efficient and sustainable way. Because there's a great phrase, if you want to go fast, go alone. If you want to go farther, go together. AI is a team sport. It's about bringing together a collection of experts that ultimately are going to mean that you achieve your AI objectives significantly quicker, more efficiently, more effectively, and ultimately in a way that's better for the planet.
Brilliant. Patrick, you get the last word.
Thank you. No, I'm just going to echo what Matt said. I think it's, it's absolutely where our mindset is as well, and the type of advice we would give our enterprise customers. I think I might add, build with the end in mind as well. I think obviously there is great urgency in terms of reaping the benefits of Gen AI. I mean, everyone can sort of feel that, the gains in productivity could be something that really, really makes a difference. But certainly I would advise, IT leadership to, take the time to solution properly. To Matt's point, surround yourself with a trusted advisory board, should we say, in terms of technology. Try and cover the whole stack as well, from top to bottom. I think that's really important to have a holistic view, not just, a bit of software there and data center and hardware and is another silo. So I think it's really, you need to have a holistic view of this. And the good news is, I think, there is I think all the parts of the ecosystem are really engaged, and there's tiger teams and on AI everywhere, and the expertise is, everyone is becoming more agile around it because of the sheer pace at which things are evolving. So, but all in all, I think it's very exciting. From an infrastructure perspective, I mean, that is we're gonna be able to go as fast as, respecting new regulation around sustainability allows us, and that will be a very important component as well. So I think there'll be, very strong growth, but hopefully controlled by, sensible regulation around, adhering to sustainability objectives.
Brilliant. Thank you. That's all we have time for this episode. But Matt, Patrick, really appreciate your time, and thank you for coming on to talk about HPC and sustainability. To our audience as well, thank you very much for tuning in. As we said, that is all we have time for, but we'll be back in about 10 minutes with the facility tour into Digital Realty's Woking and Cloud House sites, so make sure to tune in then. This episode will be available on demand shortly if you missed anything. And if you'd like to speak to Matt or Patrick, please do feel free to reach out. I'm sure they'd be delighted to hear from you and discuss things in more detail offline. As I mentioned, we'll be back in about 5-10 minutes, so we look forward to seeing you then. Thank you.